corner are all computer numeric control, lathes, mills, machining. So you can see with this kit, generally, there's a whole lot of these tubes, right? Does anyone know what those are for? What did you say? What did you say? Liquid and coolant. Yes, so it's liquid, coolant, and also washing away the swarf. So it's a combination of keeping the workpiece cold or at a temperature that's reasonable, whilst we continue to cut away at it, to actually clean the workpiece of any kind of material. You can see down here, all this material in here is called swarf, but we've cut away from it, and also a fluid to keep it lubricated. So the tool is cutting, anything from a wood, plastic to a metal. So we want to actually keep that surface at a lubricant level that is good for whatever we're doing to the workpiece. There's again a whole science in the amount of flow of that liquid, the type of liquid, so the flow rate, and how that relates to cooling, washing away, and also lubricating. So you can see here there's some examples of what they've done on these machines. This one's a turret mill, so you can see at the top in the corner here is a big turret with a shaft that rotates. This moves across and cuts the workpiece on this bed. So we hold the workpiece in these clamps. That turret will have a particular mill piece in it that we're machining at a different size or speed, depending on what it is we're cutting, machining, shaping. This one doesn't change itself. Whereas over here, similar to the mill, the other guys. There's a chuck here. There's 3 jaws on it. Those jaws come together and hold the piece in on that side. On this side, this turret comes across and machines. Can you notice what this machining head looks like? What's going on here? How many different machining tools does it have on it? A lot, right? So what this does is it actually moves to machine with the tool of choice. So you can actually do multiple types of machining operations in the one job because of that head. Traditionally, you'd have basically a tool side and a piece side where you'd have to manually put in the tool. Now, we've worked on these, again, at Swinburne and Dyson. I had to use a lathe, a manual lathe as well, where I'd then go and machine manually with one tool. With this, you program it, and it will change for you. So you can imagine like drilling holes, machining slots, shaping a piece of metal, particular mandrel size, or rounding and chamfering off, or putting radius on the edge. That can all be done with this thing without changing anything, just basically out the program. Again. But this one has an arm that I believe replaces the tool. So we actually have another level of automation going on with this than what we did down there. If you're able to program your workpiece on a series of programs to utilize whatever's in the turret, the replacement turret to the work turret, this is just gold, this machine, because you don't need to take anything out, it just does it for you. Like, absolute gold. As you can see along here, we have a whole lot of gas canisters. That brings us to this. This is Milan's baby. This thing fuses and cuts using this massive laser. It's fed by these gas lines on this bed. It could be that you're machining with the laser, cutting all the way through a really crazy, plate sizes. You think about something like this. Oh. The cleanness of that cut, but they'll combine. Sorry, this is fusing. That's actually fused on. That's not cutting. They fused that on. So it would have been on there. They probably would have machined that, because that's a machine line there from one of the mills. They put another substrate on. They've probably been testing how they can. Solid. And it's got a bed in the middle that it uses through essentially an inkjet style of head. And they've got quite a lot of, all the way around here they've got computer consoles.
You see anything?
So we have very good relationships with Martin Leary, Paul Porter and Glad. We've had quite a few students who've come through here and done particularly parts of their honours projects with this kit. The good way for that to happen is for you to be nice and to have very specific things that you need doing where we can actually broker that kind of relationship if you need it. If you don't need it, we're not going to broker that relationship because they're very busy here.
100% correct.
Yeah, exactly. Right? Be nice, but it's also, it's mutually beneficial for these guys if there is a really interesting project. And I'll show you some around here that are actually our industrial design students, FDM machines. So remember I talked about the toothpaste and ABS? Yep. So what these machines do is they actually pump out a bit like the machines you've got over in building 45. Sorry. That's right. But we're using ABS, which is a lot more functional. So we can start to test mechanical aspects and dynamic, clip aspects of a different material. They don't have to have it in there anymore. That's all right. If it's going, we're going, but so we're creating micro and nano level metallic structures based on heat, pressure, and the substrate, the powder. Within these, there's little platforms inside, and they just drop. It wipes the powder back across, drops again. When they're on, what you actually see is a bit like going to I don't know, what's a nightclub that's open now? I don't go to them anymore. Where there's lasers, right? You know the laser shows? You'll see these little lasers just like basically jumping around the bed. And it's like, a bit like being where I used to go to nightclubs, not anymore. But basically that's engaging with that powder and turning it into a layered structure of metal. So that's what's here, and that's what's potentially available. Who's seen the RMIT MACE? Mechanical research, biomedical research, advanced manufacturing research. Microfluidic systems, like just the crazy kind of stuff where you go, oh wow, like they're actually analysing where they're placing something.